All right, hi everyone. Thank you for attending today's session on how to run a successful AI or ML startup. My name is Meg Quintero, and I am head of programming for the Advancing Women in Product Seattle chapter. For those of you who have not joined an AWIP event before, our organization was founded in 2017 to address the gaps in tech management roles filled by women and other underrepresented groups. To address these gaps, AWIP has a two-pronged approach of skills-based workshops like this one today, as well as an ambassador program to pair high-achieving product leaders with executive mentors who can open the door to their next leadership opportunity. Since its founding, AWIP has experienced massive growth with a membership of over 12,000 members. It has opened chapters in Paris, San Francisco, New York, Seattle, London, Berlin, Chennai, Boston, and most recently, DC. Today, we are proud to host this event with our newest AWIP Seattle sponsors, Madrona Venture Group and Madrona Venture Labs. Madrona Venture Group is the leading venture investor in the Pacific Northwest. Over their 25-year history of investing in technology companies, the firm has had 21 IPOs and has helped companies as diverse as Amazon, Smartsheet, Rover, Redfin, and Snowflake grow and thrive. MVL is Madrona's incubation program that works with founders to help make their vision a reality by bringing technical and business expertise to the table. Today, we are joined by Jay Bartow, the CTO of Madrona Venture Labs. Jay is a technologist, machine learning enthusiast, and serial entrepreneur whose startup career spans over 20 years and includes co-founding a number of venture-funded data and analytics startups, which have been acquired by companies such as Microsoft, NetRatings, and Hulu. Outside of his role at MVL, Jay enjoys playing music, collecting guitars, and tinkering with his 3D printer. Before I hand it over to Jay, I'd like to call out that we'll be doing a Q&A session at the end, and we'd love to hear from you. So please submit your questions in the Q&A form. All right, over to you, Jay.
Thanks, Meg. I hope everybody's doing well, and I really appreciate the opportunity to work with AWIP and present my experience starting machine learning companies to all of you. So let's dig in. Let's see. So a little bit about me, maybe repeating a little bit of what Meg said. I am CTO at Madrona Venture Labs, and as Meg mentioned, Madrona Venture Labs is a startup studio inside Madrona Venture Group, the Pacific Northwest's oldest and largest venture capital firm. I encourage you to all check out our website to learn more about how we work with entrepreneurs and start great technology companies. And I just want to say, and I'll also remind you at the end that we're also happy to chat with any of you one-on-one about your ideas and questions you may have about your own startup ideas and also about working with MVL. So just continuing down the list, as Meg mentioned, I've been a serial technology entrepreneur in Seattle for 20 plus, well, almost 25 years. I've been a part of 6 startups. I've co-founded 4. I've been through a number of acquisitions. And, you know, I do have a particular interest in applying machine learning technology to business and consumer applications. As Meg mentioned, I have a lot of experience working with venture capital. All my startups were venture capital funded. And in the startups and also in MVL, you know, I typically play an engineering and product leadership roles. So a little bit more about my background. These are some of the verticals and industries I built startups in over my career. And as you can see, it's a pretty wide range. This wasn't necessarily a deliberate plan. I always just was looking for the next cool problem to solve with technology and machine learning technology in particular. So you can see varied verticals such as e-commerce, online advertising, travel, medical informatics, and mobile consumer video analysis. And then more recently at Madrona Labs, my colleagues and I have worked on a number of applications and startups across still more verticals and industries. Much of what I'm going to share with you today are lessons that cross all of these verticals. The basic ingredients are still lots of data and machine learning technology combined in unique ways to provide value to a particular customer. And so here, areas include people analytics, intelligent e-commerce for home decor, online identity validation, and automated sensitive data identification and redaction. And still a few more here, RPA and business process management, real-time budgeting and forecasting collaboration, security compliance automation, and most recently, conversational AI technology for back office healthcare applications. So again, lots of different applications and verticals, but all with a common theme of data and machine learning combined to provide some kind of unique product value. Everything good so far? Everybody can hear me? I'll take that as a yes. Okay, so part one, the era of AI and ML. So I'm pretty confident in saying that, we're in a golden era of AI and machine learning development. And it's a really exciting time. This may be obvious to a lot of you, but many folks my age and older can recall a time where it hasn't always been so rosy for AI. There have been several AI winters over the last several decades where little to no progress was made for long stretches of time. And the outlook seemed pretty bleak. But today, many very challenging problems now have robust solutions due to three things. One is huge amounts of accumulated data, gazillions of new bytes a day, technically speaking. And also the availability of massive amounts of compute power, and especially specialized hardware like GPUs and TPUs, graphical processing units and tensor processing units. And finally, the reemergence of neural network algorithms, AKA deep learning. The neural network algorithms have been around for years and years, and they've come in and out of favor over, arguably 30 or 40 years, but their most recent reemergence has really been astonishing and game-changing. And when I say robust solutions, I mean in some cases, models showing better than human level performance on some tasks. So for image classification tasks, for example, there are some benchmarks that have come out just in the last few years that show that in some really interesting cases, machines are better than humans at these classification tasks. So things that were really unheard of only maybe 5 or 10 years ago. Additionally, many industry analysts are estimating that the artificial intelligence market will be worth upwards of $300 billion by 2025. About 10 years ago, Mark Andreessen of Andreessen Horowitz, a really prominent VC firm in the Valley, wrote an essay entitled "Why Software is Eating the World," an analysis many felt was prescient. More recently, Stephen Cohen and Matthew Granade from Point72 made a similar claim that while software ate the world the last 7 years, learning models and machine learning will eat the world in the next 7 years. And so given all this, there's really never been a more exciting time to start a machine learning company. So briefly, what is machine learning? I think probably a lot of you have at least a basic sense of what machine learning is, but I'll cover a little bit here quickly. So in machine learning, we teach, or sometimes we say train, a machine or an algorithm to recognize patterns in data. And typically you need lots of data. Sometimes refer to the data as examples to teach the algorithms. And there's actually probably a good 5 or 6 different types of machine learning, but the two basic types that I'll talk about here are supervised and unsupervised learning. In supervised learning, algorithms learn patterns from labeled examples. So I have a little bit of a contrived example here of teaching an algorithm to recognize pictures of a dog or a cat. And so in order to do this, we need to gather a lot of pictures of dogs and cats and have a human label those pictures with the right answer. And with unsupervised algorithms, algorithms try to find structure in the data automatically without help. And so that sounds really appealing. And if you look at my picture on the right, that's the result of a clustering algorithm. Some of you may be familiar with that from statistics. Finding distinct groups of patterns in the data here indicated by different colors, and doing that automatically. But I want to make particular note of supervised machine learning because it's the most common technique, and the process of labeling data can be resource intensive. And I'll talk more about labeling later on in the presentation. So if you want to train a model to recognize pictures of cats and dogs, I need to feed the learning algorithm a number of examples, data basically, of cats and a number of examples of dogs, each with an appropriate label of cat or dog, so the so-called right answer. So here, maybe I'll need 10,000 pictures of cats and 10,000 pictures of dogs, each with a label assigned by a human. The goal is that after the training process, ideally the learning algorithm will learn to accurately tell the difference between the two classes, dogs or cats, when given a new picture whose class is unknown. So that's kind of a real high-level basic overview of machine learning. And again, I'll be coming back to data labeling for supervised learning tasks, because that's really the most common technique used in consumer and enterprise applications. So just a little bit more here about machine learning and the kinds of applications it's powering these days. I'm sure you guys are all familiar with most of this stuff, but maybe perhaps didn't realize that machine learning was at play. But machine learning is behind all of these technologies and applications. And very importantly, all of them are enjoying newfound power and accuracy due to the emergence of neural networks and deep learning. And of course, what I mentioned earlier, lots of data and lots of computational power. So, just as an example, if you've got an Alexa Echo device, there's many elements, that just set off my Alexa device. There's many examples of pattern recognition and machine learning powering its capabilities. Some of it's running in the cloud, some of it's running actually on the Alexa device, but Alexa really wouldn't be possible without the advancements in machine learning. Okay, so broadly, there's two types of machine learning companies, and I'll characterize them as horizontal and vertical. Horizontal companies offer data science and machine learning tools and platforms that can be applied to many types of problems in many industries by technologists. These companies and products leave the business problem definition, the procuring of data, and solution development to their customers and users to solve. There's a number of weaknesses of horizontal machine learning companies, especially from a startup standpoint. The biggest of which is that machine learning technology tends to become commoditized quickly. So remember that phrase, because it's going to come up again in the presentation later on. As quickly as things are happening with the evolution of machine learning technologies, it really doesn't take long before everybody's got the latest solution. And that's going to be an important concept later on. Open source tools and platforms offered by the community and big tech companies and cloud providers, offer a tremendous array of choices and solutions, for data scientists and machine learning engineers to build solutions. But a startup competing in this space is very difficult because, it's hard to compete with free or cheap. The net of it is that this is a tough area for machine learning startups seeking investment, especially from venture capitalists. It's not to say it's impossible, but there are tools and platform companies that do get funded, in particular companies that operationalize or optimize an open source machine learning solution for usability has been one area of opportunity recently. But as a rule, horizontal is much harder. You really need to have something special. And so my general advice is to avoid starting a horizontal machine learning company. So let's contrast horizontal with vertical machine learning companies. I've got a lot more of a precise definition here for vertical machine learning companies. So I'll take some time to read these out because they're pretty important. So for a vertical machine learning company, the founding DNA of the company combines subject matter expertise, i.e. a domain expert, with technical expertise, and sort of a kind of a yin-yang kind of way you can think of it as. And the subject matter expert has experience in the vertical, has identified a priority problem ideally that they lived with working in that vertical, and has a contact list of industry experts to leverage for market and customer development. And of course, technical expertise builds a specific solution to the identified problem. And so very differently from a horizontal machine learning company, a vertical machine learning company offers a full stack end-to-end product. So not just the analytics pieces. So that means that they own the customer user experience and the business customer relationships. And very importantly, here's another theme that'll come up again and again. The company procures or creates or derives strategically valuable proprietary data. And of course, because it's a machine learning, vertical machine learning company, they have machine learning technology that delivers core value to the product or business. These are the types of companies that we work on and build at Madrona Venture Labs, and really the types of companies I've done in my career. And so, I'll get into the strategic importance of data in the next few slides, and vertical companies will be the focus of that discussion. Again, in general, importantly, the scope of the value of a vertical company is much greater on average than that of a horizontal company. And because of that, we recommend focusing on vertical machine learning companies if you're going to raise capital from investors. Okay, part two. How are we doing on time? Pretty well. A data perspective on your machine learning startup. So, as much as I'd love to chat with you guys about all the awesome and exciting things happening right now in the machine learning space, and I'll get to some of this more a bit later. I'll come back to it. But right now I'm going to talk about something a little less exciting, but very fundamental to your machine learning startup, and that's data. When it comes to data, I've learned through my experience that there's more than meets the eye. And there's a lot of aspects of data you really should be aware of as you contemplate building your machine learning startup. And I've gone through the school of hard knocks over the years, building different companies and learning these lessons. And so I hope this is helpful for you to know, about and be aware of before you get started. So here's a snippet of a recurring dialogue I've had many times with budding entrepreneurs over the last 5 years. And basically it goes like this. They tell me their idea, and more often than not, they're interesting, clever ideas. I respond positively, but inquire, well, how are you going to build that? And they respond with deep learning. Apparently the technology that can do anything. It's on everybody's mind. But then I clarify that I'm more interested in learning about the sources of data that will power a machine learning solution. And then they typically indicate that they hadn't thought about it much. So all of this stems from my experience building machine learning companies. At the end of the day, the acquisition and curation of data tends to dwarf the importance of the actual application of machine learning technology. Well, that sounds crazy. You may be wondering. Well, let's talk about why this is the case. So data is your moat. So very important concept. So for a venture capitalist or an angel investor or sophisticated investor who invest in technology companies, defensibility is a really big deal. The last thing an investor or an entrepreneur for that matter wants is to think up a great new idea for a product, successfully bring that product to market, only to be quickly copied by competitors. Definitely don't want that. And so you're probably wondering, well, if machine learning technologies are not the key to your value and defensibility, what is? Well, it's probably your data. And here's why. So, again, as I mentioned, kind of drilling this into you guys, progress in machine learning technology continues at a breakneck pace. But those advancements typically become commoditized quickly. Ideas spread quickly. Academic papers are published by great institutions coming up with new algorithms. And the open source software world for machine learning algorithms has just exploded. And even companies like Facebook and Google and Uber and Twitter and Microsoft, they're all releasing a lot of their machine learning algorithms into open source. And so, if you're a budding technology entrepreneur building a machine learning company, you've got lots of tools to choose from and at your disposal. And so what you really need is data. And so how do you ward off your competitors? Well, again, data is likely to be your defensive mode against your competition, not your machine learning technology. And this is especially true if your data is proprietary. So you've captured or collected data with your own technology or sensor or service or application. Your data is longitudinal, so you've collected a lot of it over time. Going back to supervised learning, your data is labeled. You've spent resources augmenting the data to make it more valuable. And then, finally, your data is heterogeneous. So, you may be not just relying on one data source, but you're relying on multiple data sources that you've culled together or stitched together in unique ways, and using that to, really have a proprietary defensive mode. And so, to be clear, your application of machine learning technology to the data, it does matter. And having machine learning experts on your staff, is super important to know how to apply the algorithms. But I would say in the grand scheme of things, it's more the icing on the cake rather than the cake itself. But be prepared. Your data strategy may have challenges associated with it. And so for the next several slides, I'm going to talk a lot about those challenges. There's a lot of reasons, depending on the type of data and the different kinds of problems you're trying to solve. There are different kinds of problems. And so I'll address a bunch of these. But here are the big themes. Arguably, most interesting data is what I've called for years SED, somebody else's data. And so someone else's data may be hard for you to get in a number of different ways. The owners may not want you to have it, or they may want you to pay for it and pay a lot for it. And so SED doesn't really create a strong defensive mode. You're really dependent on someone else for the fuel for your great machine learning solution. And this probably means that if you're using someone else's data, you don't have exclusive access to the data. Again, that's strategic for your product and company. And I've got some good anecdotes coming up about different situations that I've been through, dealing with SED. Also, oftentimes, valuable data is sensitive, containing corporate secrets or personally identifiable information, et cetera. And so, increasingly awareness of the sensitivity of data is adding friction to, say, an organization sharing data with an outside vendor who which very well be your startup. So, think a little bit about all the SED that's out there and what you could do with it. For me, just fantasizing for a second, LinkedIn and Facebook data come to mind. I can think of a million cool applications that I could build with that data. But unfortunately, and probably obviously, it's going to be difficult and expensive to procure that data. And even if I could, those companies are likely to sell it to my competitors as well, if they let me even have it at all. Okay, so, as promised, let's talk about some challenges with different data types and different types of applications and the data that goes along with those applications. There's a lot of ways to categorize data that may power your machine learning company. I came up with some broad categories because they highlight some of the challenges that have come up in my experiences. So the first type of data that I want to talk about is what I'll call my customer data. So what is it? Well, it's data your customers generate by using your product. And it can be really awesome, powerful data. And typically, at the very least, it powers things like recommender systems or matching algorithms. Think about, Facebook or Amazon. Both use a lot of their My Customer data to figure out how to get a user more engaged and find them new things to buy or new friends to connect with. And so it's really powerful data when you've accumulated enough of it. So again, just some examples like purchasing behavior on your e-commerce site, viewing or commenting behavior on your social media site or video site, maybe successful matches on your two-sided marketplace. And it really can come in all kinds of shapes and forms. I mentioned a startup that MVL worked on earlier called Vouched, which is in online identity management. And there, for those guys, their customer data is pictures of documents, things like passports and driver's license that prove who they are. And so that's really interesting data that they're collecting, and also very sensitive as well. So this stuff can really come in all kinds of shapes and forms. The great thing about My Customer data is that you own it. It's not someone else's data. And so the data is inherently proprietary, of course, contingent on your EULA agreement with your users. This is a kind of data that can be a foundation for a strong moat if you can accumulate enough of it. And again, mentioning, Facebook and Google and Amazon, let's face it, empires have been built on this type of data. And, think about how those companies have used all of our personal information to create a tremendous amount of value. And the more data we give them, the more value they get from it. It's really the stuff dreams are made out of. But there's some bad news about My Customer data. There's a chicken or the egg problem. So when you launch your company or launch your product to the public or to an enterprise customer, you have no data because no one's used your product yet. So that's tough. That's a tough chicken and egg problem. And you probably don't even really know how much data you'll need to give your product to have an edge with machine learning technology. I sometimes refer to these companies as tech later companies. Sure, every technology company is going to generate some data over time, but you have to really ask yourself, is the data and machine learning solution really core to your value proposition if you can't offer it to your early users? Or are you really just using data that you have to accumulate over time and then apply machine learning technology to it? Is that not really your core value? Is it just a vitamin? So, a big exercise to the reader here is to think about clever ways to bootstrap your initial data sources. And maybe we could talk about this a bit in the QA section. Assuming you can get your data collection flywheel turning, one in particular important concept I want to cover that aligns especially with My Customer data type is the notion of building network effects with data. And so again, if you can accumulate or bootstrap a critical mass of data, that provides foundational value, you can enter the virtuous cycle of data. This goes under various different names, but the concept is similar, and the idea is pretty straightforward. So if your product is data driven, then the more data you can collect, the better your product will be, and the better your product is, the more popular it'll become, and the more data you can collect from that increase in users. And round you go, essentially increasing your moat at each turn. And so this makes intuitive sense. Think of a review site like Yelp as an example. The more reviews they get, the more powerful it is, the more people will use it, et cetera, et cetera. And again, the challenge is to bootstrap here and get the flywheel turning. But once you do, this is really how you want to think about things. And I won't say that the virtuous cycle of data is a holy grail. There are limits to its effectiveness for some types of data and products. But in general, it's an important strategy, and something I encourage you to think aggressively about and strive to achieve, because it will protect you from your competition, and especially create a strong stickiness and loyalty with your customers, ultimately fortifying your moat. Okay, the next category is what I'll call enterprise data. So what is this? Well, it's operational data that belongs to your customer. Lately, last few years, sometimes I've heard people refer to this as exhaust data. And so, examples are things like server log files or corporate documents, communication logs, chat, email, calendar, meeting notes, SaaS data, basically core systems of record. So more and more companies are using software as a service applications for their CRMs and general ledgers and HRIS, human resources information systems. And so, the great thing about enterprise data is that, companies kick off a lot of this data in the course of their daily operations. And a lot of it's just sitting around in files, on data stores and databases. And it's really, much of it's only beginning to be utilized. And so there's a lot of great opportunities for startups to work with their customers to get their exhaust data, apply machine learning algorithms to them for whatever application, ultimately usually helping businesses just run better and more efficiently. The challenge is that this data is often sensitive. It's usually sensitive. It might be in semi or unstructured form, like text data that would come from corporate documents or communication logs. So that's an opportunity to show off some of your machine learning prowess. So not necessarily a bad thing. I've also learned from my own experience that signals in the same type of data might look different across customers. This can be a challenge when you're trying to find product market fit. So one type of particular type of data from one customer, even though it's technically the same kind of data about the same thing, may have different patterns in it because companies and enterprises behave differently. But in general, though, there's a lot of this data sitting around and just waiting to be used. Okay, so sticking with enterprise data here for a bit, let's talk about a special topic related to enterprise data, and that's managing someone else's sensitive data. So not SED, but SESD. So say you've just landed your first pilot customer who's agreed to send you over a bunch of their data so you can apply your nifty machine learning algorithms to it and return value to them in some shape or form. You're super psyched, salivating at the thought of getting all that data. And then an email shows up from someone you might not recognize from your pilot customer's organization. And it's the dreaded security questionnaire. So when you're working with this kind of data, it can be a shock when, as I said, your first pilot customer's CISO or IT sec person sends you over this oftentimes crazy spreadsheet full of 200 security questions. And the questions can be full of a bunch of crazy stuff that a startup would never have, making you feel a bit inadequate and vulnerable. And so, again, this has happened to me a bunch of times. One question I always love and look for just for grins is, please list out all the members of your change control committee. And it's like, well, let's see, we're a startup of 5 people. And so I guess everybody's on the committee, including my cat. It's like, we don't have a change control committee. We just write code, we make changes, we push. And so the answer to just about every question is NA, not applicable. So again, this can be very intimidating. So my advice here is don't be surprised if you're going to be wanting to procure enterprise data from your customers, plan for this security scrutiny. Don't make it a mad rush at the last moment. And so, that means investing in security from day one. Show your pilot customers, CISO or IT or SecOps departments that your team is comprised of grown-ups and you know how to build secure solutions. That means locking down your cloud with VPN and VPC technology, minimal authorization privileges to key resources and data, having policies in place about how no customer data leaves your cloud. So your employees are not downloading your customers' data to their laptops. Of course, everything is encrypted in motion and at rest. And maybe even like write a security white paper outlining your cloud architecture and best practices. And, start working on this sooner rather than later so that when you do land that first pilot customer, sorry, I got to move this out of the way. When you do land that first pilot customer, you're ready to go here and you're as buttoned up as you can be for a 5 or 10 person startup. I'll just mention here that there are some new audit standards emerging and getting popular that organizations are requiring their vendors to have. And one is called SOC 2. And, it's a good start in having a young company basically get SOC 2 validation and be able to present a SOC 2 certification to their customer to say like, hey, we're buttoned up, we have our act together here. And so, basically what SOC 2 audits are certifications that show an organization that there's documented information in place regarding security and operational policies and procedures, all the kinds of things that are in that dreaded spreadsheet of 200 questions. And so I'll just make a cheap plug here. I've seen this problem and pain so much that about a year ago, we partnered with an entrepreneur, Justin Beals, and helped them start a company called StrikeGraph, which is a SOC 2 certification application for companies to quickly and easily get their ducks in a row for SOC certification. So if you need to get SOC certified, please check out StrikeGraph. One more thing here, and that is that if your customer is really sensitive, which they're very likely to be about their data, offer to run your technology inside your customer's cloud or on their premises or inside their VPN. This can definitely make your architecture a bit more complicated, but if you plan carefully, you can make things more flexible, especially using things like container technologies like Docker and Kubernetes. So it doesn't have to be painful. If you have to do this breakup of your architecture and run pieces inside your customer's infrastructure later on after you build things, it will be harder. So maybe think about things like this from the start. And you may have to only run part of your technology in someone else's environment, say like, the initial data processing. Oops, sorry. Say maybe the initial data processing. I've found recently that, even offering this capability to a customer goes a long way in building trust. So, they'll have conversations with IT people, saying we'd really like this data. And they're like, well, I don't know about that. And, we'll have to, have lots of discussions and see, and just offering like, hey, we can run our technology inside your cloud if that makes you feel more comfortable. That's been really helpful greasing the skids. Okay, so next category is public data. So many of you probably know that there's a ton of public data, open source data, out on the web that's released regularly by governments and public and private institutions alike. And so what is it? You name it, anything you can think of almost. I've got here crime data and census data, medical research data, which is something I used in one of my recent startups, state and local government data, transportation data, election data, you name it, it's out there. And it's really just waiting for your creativity to figure out how to take that data and do something really interesting with it. And so the good part is that, you know, there's lots of it and it's free. The challenges are that your competitors have access to it too. So it's really not a moat. And so this is an area where your machine learning chops might give you a little bit of a head start. But, you know, again, you're still, you know, vulnerable if your sole data sources are all free and a competitor wants to come after you. And so one case study here from my past is a company called Medify. And it was a medical informatics company where we mined medical research articles with what was then state-of-the-art NLP technologies. And so we ended up stitching data together from a number of different public sources. And as I'll recommend later, like the more you can mix data together from multiple sources, the better moat you'll have. But we used a whole bunch of public data from PubMed and National Institute of Health. And it was super helpful and definitely accelerated our product development. And so I guess my advice with public data is, you know, use your creativity to find interesting data sources and build applications on top of it. But if possible, try to augment it with other data, especially proprietary data, as you know, this will help your moat. Okay, next category, and we're getting through these here, so hang on. So next category is what I'll call consortium data or industry data. And basically, industry data is where a number of companies contribute data for the common benefit of the industry. So a great example is the travel industry. There's quite a bit of data that all the airlines and many hotels contribute to a common database. Multiple listing data from real estate is another example. So, you know, at least at one point, you know, companies like Zillow and Redfin and so forth powered their analytic services with data like this. And so the challenges are that you know, this is SED. It's someone else's data. And here there may not just be a single owner, but multiple owners. You probably will have to purchase it. And you may need permission from multiple entities to obtain it. So that can be challenging. Some people try to get this data by scraping commercial websites, but you know, that can be a challenging solution, particularly long-term. You know, gathering large data via scraping is difficult. And again, you know, if someone finds out you're scraping their data off their website, you know, they very well may ask you to stop or block you. Block your crawler and scraper to keep you from gathering someone else's data. And this is kind of a gray area of the web, like, you know, what data can be scraped and what data cannot be. And so you'll, you know, just have to evaluate that on a case-by-case basis. So another case study here from my background. You know, I got a really strong dose of working with industry data at a travel startup I did several years ago called Faircast. And this is a great story. A UW faculty member, Oren Etzioni, who's now CEO of AI2, wrote an academic paper about predicting changes in airfare prices. And, you know, again, this is a great entrepreneur story because his motivation was based upon a real frustration he had buying consumer plane tickets. In particular, one particular destination he went to repeatedly from Seattle. And, you know, he found that prices were always volatile and changing, and he wanted to have an upper hand knowing the right time to purchase a ticket when they're cheap and not when they're expensive. Of course, the airlines want you to believe that the farther out from the departure date that you purchase your ticket, the lower your price will be, but that's actually not the case. So my partner, Mike Fridgen at Madrona Venture Labs, and I built the technology and product for Faircast. And I'll also note that Madrona Venture Group was involved very early in Faircast. And in fact, we incubated it at the Madrona Venture Group offices, working on a prototype of a technology before we ultimately got funded and spun out and became our own company. And so, you know, in my mind, Faircast is a kind of a quintessential example of a vertical machine learning company leveraging industry data. So just a little bit more here. Let me move this out of the way. So, you know, again, what we were doing at Faircast was forecasting changes and future price direction for airfare and hotel rooms. And so in order to do this, you know, again, we had really smart data and machine learning people on staff, several PhDs, but we required huge volumes of priced airfare and hotel room data collected every day. And what we quickly realized was that few data providers could fulfill our volume requirements. And of course, we also quickly learned that the arcane nature of airfare pricing mechanics proved to be a big learning curve. So, you know, again, this is a great example of a challenge of working with data, is just even understanding the data you're working with. And then I think, you know, most importantly, you know, we were really vulnerable. We were providing a service for consumers that consumers really loved, that provided transparency on the direction and state of airfare prices at any given moment. And as you can imagine, there were some airlines that didn't like that. They didn't want their customers to have transparency into their pricing structures. And so, you know, there was always a worry that our data sources would be shut off if our product was too powerful. And, you know, sure enough, we did have an airline shut us off. That wasn't so bad that one particular airline shut off our access to their data. But, you know, our concern was, well, you know, what if everyone else follows suit and we get all of our data shut off? So, you know, there were some sleepless nights worrying about this. And, you know, definitely a part of doing a startup, you know, leveraging this kind of data, kind of par for the course. So, you know, I'll say that I learned a lot of hard lessons about data at Faircast. You know, in the beginning, we thought it was a machine learning company, and it certainly was. You know, we were really concerned about how good the machine learning technology could be and would it be accurate enough. But later we realized our data challenges were very significant, much bigger maybe. And again, that's not to say we didn't do amazing things with data, or sorry, with machine learning, but the data challenges were much larger and fundamental to our efforts to build a great product. We overcame the challenges, so it's a happy ending, but not without a lot of hard lessons learned. Okay, so the last type I want to talk about here is personal health information. And I guess this is a type of industry data, but I wanted to call it out given how desired it is. So what's healthcare data? Well, you know, it's everything you would imagine associated with the healthcare industry, and especially patients interacting with the healthcare industry. So doctor's visits and medical tests, procedures, et cetera. It's all recorded somewhere, usually in hospital information systems and other places as well. And, you know, sometimes I wonder if this is the holy grail of data. I mean, this is, you know, a lot of entrepreneurs want to work on healthcare startups, especially machine learning, people with machine learning and data science backgrounds, because they know that all that data must be sitting somewhere. And let's face it, you know, it's a great mission to be helping sick people and using technology and data that make the healthcare system better and more efficient. So I meet a lot of people who want to do startups in this space. The challenges, as there often are, is that, you know, I think most of us know that there's strict data privacy laws protecting personal health information data. So, you know, HIPAA laws, I'm sure most of us are familiar with. There's also some big 800-pound gorillas in the room, hospital information system companies like Epic and Cerner. I'll just say that those companies may have some interest in holding on to their data, even though technically speaking, the data doesn't belong to them, and it really belongs to us. You know, we have a legal right to all of our healthcare data, but if you've ever tried to get copies of it, you'll know that it can be really challenging to procure. And of course, you know, working with healthcare organizations is notoriously slow and time consuming. But, you know, I will say that, you know, whenever talking to entrepreneurs about this topic, you know, I try not to be too discouraging. I just try to warn them that they need to be prepared for the time it will take to get data, to build a product, and then ultimately sell the product back into healthcare. So my advice here is that, you know, if you're going to go into this space, conserve your resources. Expect things like data acquisition and product market fit cycles to just take a lot longer, certainly than you'll want them to be. And then if you are a technologist, you know, seriously consider having a co-founder with some domain expertise. So someone from healthcare, you know, who can help facilitate a lot of these key relationships you'll need in order to get your foot in the door and gain trust. But generally expect things to take longer. Okay, so you're probably wondering, well, what's the best data? Well, you know, it's a mix of heterogeneous sources. You know, my advice is to try to bring together multiple siloed data in new and unique ways. Maybe some is public, maybe some is proprietary, maybe some of it is data you've collected off of from your product, you know, et cetera. But the more data you can bring together in unique and interesting ways, and then apply machine learning on top, you know, I think you'll have a better moat, and it will be harder for your competition to replicate. Okay, a few other gotchas here. I mentioned labeling earlier. A lot of people are caught off guard by labeling. You know, it's great if you can get your hands on a great data set, but if you have to label it by hand, you know, again, in my contrived dog and cats example, having someone go through and label it, it can be time consuming and expensive. And, you know, labeling cat and dog pictures is one thing. I think I could get a 10-year-old to do that pretty reliably. But if your data is more domain specific, say healthcare data, then you may need someone with deep domain expertise to label the data. And that's going to be harder to find those people and incentivize them to do, you know, what can be very repetitive rote work. And it can be challenging to label data in a consistent and statistically sound way. Again, you know, labeling can be kind of mind-numbing, and so it certainly can be challenging. I should mention there are lots of situations where you have supervised learning problems, but you don't need to label data. Because you can get labels for data in the context of whatever you're doing in your applications. Not to get too down in the weeds, but like at Faircast, since we were doing forecasting on longitudinal data, we could train our models on historical data and essentially do something what's called backtesting, which is looking in the past to see what the answer is on models that were trained on data in the past. Again, we were predicting changes 1 or 2 weeks out. So we were able to look at a lot of historical data and ultimately see what the label should be because all the data was longitudinally historical. I hope that made sense. But there are situations where you can analytically derive labels versus having to label it manually. And then again, you know, I'll bring up sensitivity. Giving sensitive data to an outsourced labeling resource is a real no-no. The New York Times had a great article maybe 18 months or 2 years ago where they did an expose on all these offshore data labeling shops, most in Asia. who were doing a lot of labeling for technology companies in the West. And some of the things they found in terms of the kind of data and the sensitivity of the data that was being haphazardly exchanged with some of these labeling companies was a real eyebrow raiser. So, if you need to do this, you'll have to do it, but, know that it's coming and think about, how to do it optimally and economically. Okay, so finally, I think we're good on time here. I did want to mention some things that are happening in the machine learning space, especially the last several years, that actually have an interesting impact on data and how much data you'll need. So these state-of-the-art deep neural networks I mentioned, instead require huge amounts of data and computational resources to train. That certainly was the case for many years. And, as these models get bigger and bigger, unfortunately, only the largest and wealthiest technical organizations have the resources to create these models. And so a lot of really smart machine learning people, both from industry and academia, go to work at these companies because those companies have the resources to work on these more sophisticated models. So that kind of leaves startups with a short end of the stick. But there's more here that meets the eye because new models and methodologies have come into play and are getting more sophisticated that actually decrease data and computational resources. So there's a concept called a pre-trained model that's related to something called transfer learning. And that's where a large deep neural network model that may have taken millions of dollars to train can actually be fine-tuned for specific tasks, again, with minimal training data. And this is true both in the computer vision area and the natural language processing area. In fact, maybe some of you noticed this past summer that there's a tremendous amount of buzz around something called GPT-3, which was developed by OpenAI. And essentially, this is a language model that was trained on a massive corpus of data. I think Wikipedia plus web crawl data, and a giant neural network was trained from this data. And so it cost millions of dollars to train, but it turns out the model is really amazing and does some really almost kind of freaky stuff. It's really, although it has classification capabilities, it also does really interesting natural language generation. And so, it can generate like shockingly interesting but novel textual passages such as essays or stories or blog posts or tweets or poems. You name it, it's pretty amazing. And it's making a lot of people ask out loud, like, has AI finally arrived? And so if you're interested in this kind of stuff, look for GPT-3. And you'll see a ton of stories that came out late last spring and over the summer. And it's really got the whole ML world abuzz with the potential here. And so the point is that ultimately that these pre-trained models, some are not accessible, but many of them are in open source, are really great shoulders to stand on for a startup. So instead of having to pay millions of dollars to train your model, you may have to pay almost nothing. Just use a small amount of data to tune it to your application, and you're good to go. So definitely good for startups. But the flip side is this bad for your moat? So if I'm a startup and I can get access to something like GPT-3 or something like it for free and build a really cool novel application, so can my competitors. And so, that makes that really challenging. But, again, all of this stuff is happening at a breakneck pace. And it'll be really interesting to see, even in 2021, just what happens with technologies like GPT-3 and BERT, and how it really raises the waterline and all the boats for everybody. So that's what I have. Go build your machine learning startup. Just another plug for Madrona Venture Labs here. We love working with budding entrepreneurs, helping them with their startup ideas. So happy to chat with any of you. You can reach me at j@madronavl.com, and happy to talk about just your startup idea or questions you may have, or talk more about working with Madrona Venture Labs. And I'll just say one more thing here, and that is that this presentation was based upon really one blog post I wrote last summer. Most of this content is in the first blog post. I have another blog post, sort of part 2 of Anatomy of a Startup, that talks about finding product market fit for basically the trials and tribulations of finding product market fit for a machine learning company. There's definitely some other gotchas and things you need to be aware of. So if you're interested in that, I encourage you to check that out. Those are the URLs. You can find them just by going to the Madrona Venture Labs website, or reach out to me and I can send you the URLs. And that's it. And so I think we have some time now for some Q&A.
Awesome, thanks, Jay. So first question from the audience is, you talked a bit about scraping data from public sources. Can you give us a few examples of companies that have done so and grown quickly? Would you consider ZoomInfo or Seamless.ai as these types of companies? And if yes, what did they do to scale and when using scraped data?
Well, I'm not sure in those two specific examples, how those companies gather their data and what they do with it. I'd be happy to look into it further. I'll just say that, again, reiterate that depending on the kind of data you're scraping and who you're scraping it for, you can irritate easily the owner of that data and the person who's presenting that data in web-facing form. And this can be for a couple of reasons. One is that unlike a user who just clicks around on a website and reads a link and then clicks another link and reads the page, a crawler and a scraper can do this at a breakneck pace. So it can whip through your entire site really quickly, gathering all the data. A computer doesn't get tired. And so that can put additional computational resources on the website that contains the data. And that's how you might end up being noticed. Not that I'm, looking for ways to help you be sneaky about collecting data, but usually scrapers are noticed because they get too greedy and they try to collect too much data quickly. The other reason, of course, that people don't like their website scraped is because, sometimes it's because the data is proprietary. And, for whatever reason, the company who's presenting the data on their site may have paid to get that data. And so the last thing they want is someone stealing it from them for free. The only other thing I would say here, I think, just as I think through this, is that there have been times in my career where I've had a relationship with a data vendor, and I've said, great, how can I get the data transferred to me? Do you have an API I can hit? And they've said, you know what, we don't have an API. We just have our website, it's hooked up to a database. It's challenging to get our IT department to build APIs. We don't have the technical resources. So go ahead and scrape our website if you can do that. And that would be fine with us, given that we can't provide data to you in other ways. So I hope that's helpful.
Awesome, thanks, Jay. So the next audience question we have is, when it comes to sensitive data and systems that may operate on that data in a black box fashion, how should one think about auditability and explainability of these systems in a way that earns trust while maintaining sufficient distance or maybe even zero knowledge from the specifics of that customer's sensitive data?
Yeah, so, one thing certainly with sensitive data that can happen is that the owner of the data, or in conjunction with you and your company, can anonymize the data before it comes to you. So, for example, if you think about healthcare data and a machine learning product that say makes predictions about some aspect of someone's health, they may not need a lot of the actual sensitive information that's contained in the data. So they don't actually need to know the person's name or the person's social security number, or other specific demographic information. But they may need to know what type of information it was. So, for example, if there is a social security number, just using a simple example, that's in some data that's being shared with a startup vendor, that data can be redacted and replaced with basically a label that just says social security number. So the machine learning algorithms know that the social security number is predictive in some way, but they don't actually need the actual social security number. They may just need to know that data was present. Another thing that can be done is aggregating the data up to a level where the sensitive data is obscured. So again, really simple example. It's like, well, I don't need to know where this person in this row or this record in the data actually lives, but I would like to know their zip code or the county they live in. And so that level of aggregation still has predictive power, but doesn't rely on the super specifics. Of course, there's dangers here too. There have been studies that show that even redacted data or desensitized data in some cases can be combined with other data sources to reverse engineer who the individuals actually were in the data set. So it's not perfect. And, redaction technologies, are not perfect either. And so, you may find yourself in a situation where your redaction algorithm finds like 90% of the sensitive data and removes it before it's sent over to you or before you use it for anything. But there's still that kind of 10% out there that in theory, could be discovered or leaked in some way. So it's really about, there's no perfect security solution unless you completely cut yourself off from the world. So, it's really can be a negotiation with your data provider and lowering the probability that any sensitive data is exchanged and potentially leaked.
Awesome, thanks, Jay. So another one we have here is there have been some recent very public data breaches from top Fortune 500 companies. In your presentation, you talked a bit about SOC compliance. How would you recommend emerging startups balance moving quickly and with limited resources with being intentional about the security of their data? How can startups prevent being blindsided and be proactive?
Sure. Great question. As I discussed, earlier, being, getting your ducks in a row around security, can be, is a just really good thing to do in general. So, I would say like 10 years ago, like a startup, may be more likely to have the attitude of like, well, yeah, we'll build a secure system, once we, get our MVP off the ground and we get some customers, we'll come back to the security part. And usually that doesn't end up well when companies do that. And so, I've learned my own lessons that like start with a great security culture and infrastructure from day one. And so maybe that means you're bringing on a security expert onto your team earlier than you might have, especially given the kinds of data that you ultimately need to build your product. I guess the other thing I would say about SOC 2 is that, a big part of the thesis for, raising money for StrikeGraph was that, a lot of vendors, startup vendors were just getting choked off from getting customers. The entrepreneur, Justin Beals, had some, great stories, even just from his personal experience being CTO of a startup where they had a deal with someone within a large company to procure data from them and and build a product with it. But then the IT sec people stepped in and said, we need you to be SOC 2 certified before we're going to let this happen. And so it turns out that prior to Justin's company and his product, getting SOC 2 certified was a really long, arduous, circuitous journey that involved consultants. And interestingly, ultimately, a CPA is who grants SOC 2 certification. So, a lot of times it's like, and increasingly, you have to be SOC 2 certified to get that customer. And so it's a super bummer to get down the road, with a pilot customer or a set of pilot customers, only to find out that, right when you get to the starting line, right when you think that week, you think you're going to get your first batch of data sent over, the security questions show up, or someone is saying like, you need to do this first before we'll give you data. And again, heard lots of anecdotes from people who lost deals because of it. Justin had a great story about a deal he had in hand, and it took him a number of months to finally get SOC 2 certified. And by the time he did, their sponsor at the company, at the customer company, had left. And so they had to start all over again.
Great, thanks, Jay. So beyond some of the ones you've already touched on, what are some of the consistent issues you see with early stage AI and ML startups?
Well, so I guess I'll reference the second blog post, for this, because there are some trials and tribulations, to what I characterized earlier as finding product market fit for a machine learning company. And what I mean by that is that, say you're an experienced technologist or machine learning person who has worked in large companies, worked with a lot of data, and knows machine learning well. And one day, through their work at the large company, realizes that they see an opportunity for a product that doesn't currently seem to exist. And so they form a hypothesis that like, hey, I bet if we could get this certain type of data from these kinds of customers that we work with, say right now at the big tech company, and we apply this kind of machine learning to it, we could provide a lot of value and be a really big company. And then, as the idea develops, presumably someone like investors, for example, are asking like, well, are you sure you can really do this? If you really get that data, do you think that signal is in there, and can you capture it with machine learning technology? And that's where, a technology entrepreneur has to hedge her bets on, whether or not this can be done. And so what that means is probably raising some money under the promise that this can be done, but then ultimately going out to lasso those first pilot customers, getting the data, looking at it for the first time, applying that machine learning for the technology the first time, and hoping that all goes well. And oftentimes it doesn't. Oftentimes, I joke sometimes about the fundamental theorem of data. There is none. I'm just making that up. But if there was, it would be that all real world data is messy. It's not textbook data. It's noisy. It's got a number of different signals convoluted into it. It's missing values, et cetera. Anyone who's worked with data knows this. And so for a machine learning startup, you're really kind of making a bet when you get started that you can actually do what you think you could do. And again, it could be that the machine learning entrepreneurs are really experienced people, but until you actually get that data from those first pilot customers, you really don't know how well things are going to work. And so the reason I characterize this as product market fit is that, you may find that you thought you could do something, but you can't, but you can actually do something else. And is that still valuable to the customer? So you might return results to the customer. So maybe the original premise was, yeah, if we can get this data from these pilot customers, we can apply this kind of machine learning technology and be 90% accurate or 95% accurate. And the customer says, yeah, if you can be 90% accurate, I would buy your product. And so what happens is the startup gets their first batch of data, they run their models. One problem they may find is that they actually need a lot more data than they thought they did to train their models. But ultimately, what they bring back to the pilot customer is 70% accuracy. Okay, well, how's 70% accuracy? Is that still good? And for some customers, it might be good enough, but another customer might say no, depending on the application. Another customer may say, no, that's not good enough. Let's part ways. And the entrepreneur may say, okay, well, I think I can get to 90% accuracy over time, but I'll need another year's worth of data from you or something like that. And so it's a bit of a crapshoot when you're building those first models to really know, like, is the data going to be the way I think it'll be? And since you've never seen it before, is this something I can really do something with?
Awesome, thanks, Jay. So from an ROI perspective, data and ML startups seem to require significant upfront investments in security and data platforms. Do you mind sharing more about the business side of things between data and non-data startups? How are they different?
Well, I mean, I guess I would say that, certainly data and machine learning startups can be really valuable and can get valuable really quickly. And that's what sort of sets them apart from, non-data machine learning companies. And so that's why venture capitalists want to invest in these kinds of companies, because, going back to some of my earlier material, if you can get that flywheel turning and get, more and more data and more customers and a better and better product, you can become really valuable really quickly. And again, the more data you collect, the more valuable and the better your product gets, of course, and the more users you get, the more valuable you get. And so, think about, all the, internet, latest batch of internet unicorns, startup companies, even there was some great press in GeekWire recently about, quite a few, big companies that have grown up really quickly, by leveraging data and machine learning and technology in general. That's exciting to people. And that's why investors want to invest, because they want to see their money not only grow significantly, but also to grow quickly. So there's probably other facets to that question to talk about, but I think that it's the reason why there's so much interest, in these kinds of companies I've been talking about.
Awesome, thanks. We've received a question around, just generally talking about scalability issues and best practices. To extend upon that, what are some things that you can do when you're early on as a startup that stops scaling that you have to think about later?
Say that again, that stops scaling?
Exactly, yeah. What are some tips and tricks for early ML and AI startups that maybe can be used in the beginning, but might not scale as you grow?
Well, I think 10 years ago, there were a lot more pitfalls around these kinds of things, but today with, flexible and extendable cloud technologies, scaling is a lot easier than it used to be. I mean, I think from an architectural perspective, you do have to think through, how you lay things out and set things up, and where bottlenecks are in your processing pipelines, and how to be able to scale those parts of the pipelines where there are bottlenecks. Certainly, there's more tools and platforms, especially in open source and provided by the cloud providers, that help with these things. But that said, I do often see startups worrying about scalability too early. And so, it's not unusual, and this has been true for a long time, for someone to start a company and hire a really great engineering team that's experienced. And the goal of the company is to become really big quickly. So we better build a really scalable infrastructure from the start. And that can be a real pitfall and death knell, to focus too early on an architecture that may not have found product market fit yet, and may not need that scalability. And so, unfortunately, in the short term, a lot of capital and resources and very valuable resources and that the startup has with the money they may have raised, kind of gets put towards the wrong thing. And it's a shame to see a startup die when they have a beautiful back end, beautifully thought out, beautifully scalable, but they have no customers, because they really didn't think through ultimately what they were doing and found product market fit. So it's tricky. I'm always pushing the concept to entrepreneurs about MVP, minimal viable product. And it's a concept that seems natural to me, but I've definitely noticed a lot of entrepreneurs struggle with the MVP. A lot of entrepreneurs have a really crisp vision of what they want to build, and they want the first version of the product to be a really nicely polished, V.1 that they know is going to be wildly successful, and they tell their engineering team, get ready for an onslaught of traffic. But unfortunately, again, it never happens. And so, really, I recommend that people really kind of focus on MVP and fast iteration, and the lean startup method of trying and experimenting and hypothesis testing, to really make sure that you've built somebody or you built something that people really want to use. And so it can be a good problem to have where suddenly it's like, okay, so we spent minimal resources building that back end. Now we have to scale, and we have to scale quickly. And so that can be a problem too. So you got to kind of have both in mind when you're getting started, and have a team that can be flexible enough to be scrappy and agile early on, not overthink things, but when the time does come to scale, to be ready to go, and have an idea in mind about how to measure your architecture, find the bottlenecks, and then figure out whether you need to scale horizontally or vertically or some other shape and form. I mean, once you know what you want to build, certainly the tools and platforms that are out there have never been better and more powerful and accessible to startups. But it's tricky, that gradient of going from day one or day two or day three to suddenly, wow, there's all these people, is one that you really have to pay attention to when it's happening.
Awesome. So last question that we'll end with is, are there suggested resources you would point people to self-educate on AI and topics such as NLP and ML and any of these other technologies you mentioned?
Yes, YouTube. I've been a book guy my whole life. And when I was first learning about machine learning technology, close to 20 years ago now, I don't think we even called it machine learning back then. It was, predictive analytics, or some derivative of that. I remember, there were a couple of textbooks that you could buy on these kinds of algorithms, especially neural networks and different types of ensemble learning and different things. And, they were for applied math people. And I remember, and I'm not an applied math guy. And I remember reading, those books, over and over again, and sentence by sentence. And same thing with academic papers. I remember finding some really cool academic papers 20 years ago, and needing to understand the math that the algorithms were expressed in the academic papers and turned it into code. One of the great things that's happened today that's changed there is that academics now release the source code that they used, and oftentimes the data sets they used for their academic papers on GitHub. So you don't have to be like studying math formulas over and over again, at least for someone like me, over and over again. But, slowly but surely over the years, access to machine learning education and data science education has become more and more democratized. And so, publishers like O'Reilly and other tech publishers, started publishing books about like, hey, like here's the baby steps to understanding these concepts. Or here's machine learning explained for a software engineer. So, Python, okay, well, we'll teach you about multiple linear regression, not with math formulas, but with Python and or JavaScript or Java or something like that. And so suddenly software engineers, had much more accessibility to machine learning concepts. Going back to my original statement, today what's on YouTube is just astonishing to me. There's so much material at multiple different levels of complexity and resolution about machine learning. And so if you want to learn about NLP, for example, which is, again, a super exciting area right now, do a YouTube search. And I bet you'll find things where you're like, oh, that's scary. I don't know what that guy's talking about. But I guarantee you'll find something for your particular level that's something that you can understand and then build up your knowledge from there. And, the nice thing about YouTube videos, too, is that, some of them are lectures that are hours long by notable faculty at great institutions. But, a lot of them are also just practitioners who make 10 or 15-minute videos on this topic or that topic. So like I challenge you to go to YouTube and search for GPT-3 and see what comes up. You'd be surprised the wealth of educational information that's out there.
Awesome. Thanks, Jay. So before we wrap up, I would like to point out that today's session is one of many of a webinar series that we have with the Madrona Venture Labs and Madrona Venture Group partnership. So I encourage you to stay tuned if you enjoyed this session for future webinars and workshops that we'll be offering. And so last, thank you so much, Jay, for the excellent presentation and for asking all of our questions. And thank you to the audience for taking time out of your day to attend. I hope everyone has a really great day, and thanks again, Jay.
Thanks, everyone, and look forward to hearing from you.
Awesome. Thanks, folks.
Cheers.